Hello and welcome to the first AWX Community Meeting of the new year, 2024. Good to have you all here, and we got a couple interesting topics to start with, so let's dive right in. First up is Lila, talking about enabling Hashi Vault LDAP authentication. Lila, take it away.
Thank you so much, Christian. I am going to go ahead and share my screen. So let's see, share now. Okay. Alrighty, that is, okay, perfect. So cool. All right, so we are going to discuss this PR, so 14654. And the intent of this is to add user pass and LDAP support for Hashi Corp Vault Credential plugin. So basically, you're going to be able to use AWX to go into HashiVault via username or password or LDAP. And essentially, we've added username and password here. And then we made some changes to handle auth. And then we added another method called user pass auth, which is called later on. And then it gets worked into this if statement logic here, which also creates the URL for it to be able to go in and retrieve that. And then the additional pieces here, we've got the test, which tests this. We have a couple updates to the docs, and that's all for the PR itself. So this was a pretty environmental heavy piece of work. And it took quite a bit of time to get everything configured correctly. So I'm going to start off in HashiVault. Right now I'm logged in as the root user so that I can share the configurations here. So you can see that we have my engine as the secret engine. This is the engine that automatically gets plumbed when you spin up Vault and that Vault init file gets run. If we click through, you can see that it's got a secret in my root my folder, and you can see this is the secret value. So I'm sharing this because we wanted to make that secret accessible to these additional users that we've created. So if I come over here to access, you'll see we now have LDAP and user pass. If you were to run this without these code changes, you just get the token. Eventually there will be some additional plumbing here, but these were manually configured. So looking at LDAP, we come over here to configuration, users, there's an AWX LDAP admin user, and we see that it has a policy of all secrets. And then if we come back over here to user pass, we can also see, that it's got all secrets here as well. And that's important because the policies grant CRUD functionality to these users. So that way we can create secrets and access them as well. So let me come over here and share all secrets. So it grants access to the Vault init playbook, what the Vault init playbook creates. So that playbook, as we saw, creates a secret and a mount path. And then it also gives all secrets give access to that information. Okay, so we looked at that. We looked at the policies. All right, great. So now we're going to come over here into AWX. So I've already set up a couple credentials here. So I'll first demo the LDAP secret lookup. So right now we've got everything configured, and I'll click edit here so we can actually see what I've done. So we've got the server URL, and then if we scroll down, we have the username, the password's encrypted, and I did specify the path to auth as LDAP, but that's all that gets configured there. And then we'll use a machine credential. So let's see, I've already got this one set up here. Click edit again here just to help everybody. So we've got our username here, and it's calling that other credential that we just looked at. Okay, and save, and then Perfect. Okay, so we're going to come over here, edit. And what I'm actually going to do is create another credential here. So and when you click this button, you can select machine, and then it gives you the option to choose from an existing credential. So now we want to grab the path to our secret, which we looked at previously, and I'm going to just pull it from this, which I'll go over in a moment, and pop that in here. And then the key name is my key and test. Oops. Oh, and that's my fault because it's got part of the command in it. Okay. There we go. Okay, so essentially this is going in and grabbing the secret from HashiVault. So if we look over here, this is, we are exec into the tools vault and we're logged in as the LDAP user, and you can see that we can come in and extract that secret here. And then essentially it's the same thing for the username and password. So I'll come over here. And we're going to choose machine again from the modal. And then we're going to choose testing username, which we've already configured. Same path, since we're using the same mount and secret. That gets automatically created with the plumbing that we do on our end. You can see it passes. And then if we look over here, I'm also exec in on this side, and we can see my key. This is a secret value. There is a playbook forthcoming, which will actually go ahead and print out the secret, and that will be done shortly and will be featured in a later demo. So I'll return over here and stop presenting. Are there any questions?
Awesome demo, Lila. So just making sure, right? Like the credential lookup, implementation of the credential lookup is completed. If we have a playbook that uses the credential that you set up, it will work. It just we didn't have we didn't set one up for today, right?
Correct. Yes, I'm hoping to actually have that finished later this afternoon for our internal code review, but that should be done very shortly.
Nice. But yeah, I try out your code. It works.
Yay!
Thank you.
Thank you.
A lot of people have been asking for this. Fantastic work.
Yay! Thanks, y'all.
Awesome work. Okay, and then next we have David Hagemen to talk about the Readiness and Liveness probes and the HPA. And if you can put some links to PRs when you get a chance in the chat, that would be great too. Or I can find them while you're presenting.
Yeah, let me go ahead and share my screen here. Hopefully I can do it. So we'll start with this PR here. So I think we should start by acknowledging that this is not the first PR out there to try to implement these checks. It's basically just the most recent one, if you will. And what I've done with this is try to take the comments and the knowledge that was gained from the previous PRs and kind of implement it into this one. And so I've had some conversations with Christian and Hal about what is expected here, and I'm hoping that we're at a spot where this is going to put us in a good place. So we should also acknowledge that this does a little bit more than just add the readiness and liveness checks. It also kind of refactors the database migrations a bit. And those are probably, I mean, in some ways, it should be separate PRs, but at the same time they're related, and so that's kind of why they're bundled together, and that's probably where there's going to be dragons. So let's just start with the basics. Is that the documentation is that we're going to have, you know, parameters for both the task pods and the web pod, and you can configure, you know, the various you know, initial delays, the failure thresholds, the timeouts for each of those checks. And we feel like that this is valuable to expose because your Kubernetes cluster, you know, these are parameters that you may need to tweak depending on the performance of your cluster, the capabilities of your cluster, right? You know, doing these checks can add load to the system. So if you are doing development work and you're, you know, have a resource constrained system, you want to be able to have a little bit more grace, if you will. By default, at least in this initial PR, the goal is to not enable the checks at all. And that's because I kind of want to be graceful in implementing these, get these out there, have folks opt in to using those. And then once we get, you know, to be comfortable with them, then we can go ahead and flip the bit and kind of make them on by default. And of course, we want to make sure that if a person doesn't want them, they can disable them as well. And basically that is all done by tweaking this parameter here on both the task and the readiness. Basically, if you set it to 0, it will disable the checks, right? And like I said, by default, at least in this initial PR, we set them to be 0, so the checks are disabled. There's really nothing surprising here when we look at how these are implemented. Where it gets interesting is where we start looking at the implementation of the database migration. So let me see if I can pull that up. So right here is where we're looking at the database migration code. So previously, how this was kind of handled was the operator would execute into a container and run the database migration commands. There is this weird bug or feature or nuance of running the K8's execute module in that eventually it times out. It kind of can cause some really bad problems, of course, if you're in the middle of a database migration and you know, the execution pod gets ripped out from underneath you. Hal had done some great work to try to keep that alive. That had been fairly successful. So if we go ahead and we move the migrations to be part of the init container, init containers are going to run to completion. That is their goal, right? So we go ahead, we fire up the task pod. We say part of the task pod is, hey, we're just going to migrate code. We're going to migrate the database. And so it goes ahead and starts migrating the database. The web pods go ahead and start up. And if the web pods start up and sees there's a migration, what happens? Well, you're going to see that migration screen. For better or for worse, that's what you're going to see. But at least you know that your installation is in the process of doing something. It's working and so on and so forth. So we go ahead, we do the migration in the task container. And if we come back up here to, I want to make sure I find it in the right spot here. What we do here is we go ahead and we delay just a little bit before we move on to oh, where'd it go? No, I'm not finding it here. Okay, here we go. What we do is we go ahead after the task pod is fired up and it's running the migrations. We go ahead and we use the web pod to go ahead and wait for the migrations to kind of finish. And we do this in the operator to prevent us from going through and finishing up the installation of AAP, like that initial installation. Hey, or do we have a super user defined? Do we have password defined? So on and so forth. And so we don't have to delay too terribly long. So this does go ahead and use that K8's execute command. And theoretically, if the migration does last a long time, it could theoretically bomb out. But at that time, what I've discovered, or at least with my testing, and this is where I would love more testing, is that most everything is there. And this is most useful on the initial installation. So generally, it seems to work. How?
Right, and so I was about to say that this wave for migration is probably going to bomb out with the K8's exec if the migration takes long enough. And from what we have seen, would it be better to, rather than do a K8's exec here, we wait for the task pod to get to a running state before we run the rest of the AWX manage commands?
Because it's
Right.
already going to be running that wait for migration script because it's in the entry point.
Correct. Well, yes, and just yeah. Right.
So the reason for this wait for migrations is really just this is really not a great view to show this.
Delay the AWX manage command for like like creating username like.
Right. And so my observation there is that's really only done on the initial installation, right? If we're actually doing like a large migration, restoration or whatever, that stuff's already there, right? And so really what this is just to try to pause on like an initial installation to make sure the database is ready enough to go forward. And I did consider the aspect of like trying to wait on, the task pod and all that. But I was wondering if maybe if you go ahead and you set replicas to be above 1, what would happen, right? And I never did explore that aspect of it.
Let's see. So what will happen if you run multiple migration simultaneously?
I'm thinking, well, what I'm hoping would work is that it sees the initial migration has started and the second one would not start, right?
Will not start, and
it would go past into the running state. So that task pod will eventually transition into the running state before the migrations are done.
Gotcha. So I think we probably need to improve the script that we use for initializing the database to, if able to acquire the lock, run the migration. If not, then wait for migration, right? So this way that if you have 2 replicas, rather than the init container just bails out and in a like constant restart loop, it just kind of holds there and wait for the primary ones to finish its job initializing the database. So we don't get to a point where we just like recreating the init container over and over again because the migrate command bailed out.
Yeah, that could be, I could definitely see that as a room for improvement for sure.
Yeah, I also am kind of the thought of like, it might be good to get something that works okay in, and then iterate on it once that's merged. Like if we have something that works and covers most of the bases, then we could kind of iterate and make it better from there. I guess the one thing I want to avoid is like we've dragged this one on for a while, and there's been a lot of like great attempts. I'd like to get something working that covers most of the bases.
Absolutely, 100%. And there's multiple community PR that's trying to do this. I especially like the fact that this is opt-in. So yeah, we can certainly like iterate in place while we do this. By the way, like, is there any other gotchas that you want to talk about before we move on to?
Yeah, I guess probably the last thing that probably needs to be highlighted, and I didn't expose this as an option because theoretically it shouldn't necessarily need to be an option, is the actual commands, the actual checks, right? And this is where there was some great discussion in previous PRs on like, what should the command be to determine if something is live or ready? And there was a general consensus that the AWX manage check command was reasonable for the task pod, but is it really doing what we need it to do? The liveness probe is basically the same on both the web and the task. It's since we bundle multiple execution, executables in one a pod or container, we're using the supervisor to manage them. So basically, as long as supervisor's happy, then we assume that everything's happy, right? In some ways, that's a Kubernetes anti-pattern, and maybe we should look at that going forward, right? So this is to say that this is maybe an area kind of like that migration script where we should revisit the core commands that we're using and ask ourselves, are we really exposing what we need to expose to be able to have awareness to say that, hey, this task pod is ready to accept more, ready, it's alive, it's healthy, and so on and so forth. And so I don't have answers there. It's just an observation.
So I was going over the PR and I wanted to make sure something about the web pods. So the web pods doesn't have any init container, right? That will hold up the web pod will start regardless whether the migration has been completed.
Right.
Okay, good. That's something that I wanted to make sure.
Yeah, I have confirmed that you'll see the loading screen. This was tested on OpenShift. I did see that there was a small issue with like an image missing during the migration screen, but overall, yeah, you'd see the migration screen, then eventually it'll pop into the login screen.
Fantastic.
So just to make it clear for everyone, and to make sure that I'm not reading this wrong, the Liveness probe and Readiness probe for the web container, neither of them are checking migrations. They're just checking if the services are running and if you can hit the ping endpoint for API v2 ping. So the web container will be available before the task container, which makes the route available, which makes it so that you can see that waiting for migrations screen. Did I get that all right, David?
Yep, spot on, spot on.
Awesome.
All right. Alan, Chris, or anyone else, like just staring at the liveness probe and readiness probe commands, any concerns?
I love that it exists. I love that it's, if nothing else, it's like the scaffolding, the documentation, the requirements that, the SaaS want to see, which is great. So like whatever's in there as a command, I don't care as much right now. It can be replaced.
Okay. Let's see. The schema-wise, do we want to like just create a top-level web liveness and task liveness, and then underneath it, like nestle the other parameters? Like, or are flat? This is probably a question for Christian.
Yeah, it's a good question. I think at this point we can leave it flat as it is. Ultimately, I know this has come up in the past with other new parameters. Ultimately, what I'd love to get us to with the AWX operators, AWX schema, is to have it nested so that you'd have, like, in this case, web dot liveliness period and web dot liveliness initial delay. Oh, there's a typo there, by the way, not display, but delay.
Good
But
catch. I'll fix that.
yep, thanks. And then, but that's gonna require some migration logic and cutting a new like V2 AWX CRD. I don't see another way around it really. So I think long-winded way of saying let's keep it flat and then we'll handle that all with a a migration shim to migrate V1 beta 1 AWX CRs to V2 alpha 1 or whatever we call it when we do that work.
Okay. Would there be a way for us to take this PR and preserve the old behavior? So something like liveness enabled or something like that.
Don't we already have that by if you just don't set web liveliness period, that will be the old behavior?
Well, with one caveat that the database migration will still run the same. You know what? I like the new way better anyway. Let's I'm would there be any gotcha? That's the question I'm trying to ask in the back of my head.
Right.
The Galaxy folks did this like this exact switch from like running it as an exec to running it as a init container. They might actually do a Kate's job. I'll have to check, but they haven't had any issues. We do a init container for the EDA server operator, and we didn't really have any issues when we switched. So I guess historically, we haven't had any major fallout from making this type of change.
Well, let's think about the Kate's job for a moment, right? So Kate's job will essentially spin up like a container, AWX container that, and its only job is to run the migration. One benefit of that is it simplifies our init container, right? Whereas I think, like I was talking about earlier, where we had to either do init or wait, what we can end up doing is just do the wait for migration, right, in the init container. And similarly, for the for like holding on to like the code that David added earlier to like essentially wait for migration to be done before running the AWX manage like commands to register default user and stuff. That could also be just conditioned on whether the Kate's job completed. So that's also.
Yeah, it gets a little bit tricky. I mean, we implemented that for the EDA server operator initially. I did it with a Kate's job. There's some corner cases that we have to like think about and really get right there. I think the init container is a little easier than the Kate's job.
Okay.
And less error prone. But ultimately a Kate's job, I think, would be great if we can get all the corner cases covered.
I think
Yeah, I
roughly
see where you're going.
logic, it will be like on every reconcile cycle, it will be check if migration is completed, and then check if there's any existing running migration job exists. If not, create new. Else wait.
So you'd have a random name for the Kate's job rather than one name that would be reused, because you'll have conflicts.
Yeah.
Yeah. I can't remember if it's a random hash by default or not. I think it is. The other thing we have to, well, okay, so the other issue is the problem that I think we'll run into is that you want to keep the reconciliation loop idempotent. So like if we apply it every time, I guess we could do like an ignore changed or whatever it is, changed when, just that it always defaults when applying the Kate's job. Or maybe we could play around with how long that Kate's job lingers. Like you can have like a time to live on the Kate's job resource, so that you can have it live long enough that like on the second reconciliation loop, our check to see if the Kate's job completed does say yes, it completed.
If it's already completed, like exec with a wave with like check migration would tell us now we don't need to create a job, right?
Right, but if it depends on how long the time to live is set, because that Kate's job might have just already been deleted by Kate's.
Even though the Kate's job has been deleted, the actual like migration has completed, right? So if you just exec into the task container and like do check migration, you will know that no, I don't need to do new migration. Therefore, I don't create a new job. The job itself doesn't, if it's successful, doesn't need to stay around. But one benefit here is that if it failed, we can keep it around, and we can actually look at the log and see why the migration failed.
Yeah, I gotcha. Yeah, sorry, I thought you were having the migrations happen, or having the check migration step happen in the Kate's job, but you're saying do a check migrations task, then optionally start the Kate's job.
Correct.
So, okay, got it. Yeah, I mean, I would love to play around with that. I think we
really like
into that.
Sorry, I do really love the idea of being able to keep around the migration, the log for the migration in a readable way. Like digging out migration log from the operator is not fun. So that's the main thing that's called my, yeah, exactly. Kate's job log will be immensely better.
So long-winded way of saying what we have in this PR is wonderful. There's still a couple improvements that we would love to make, but I don't think it should hold up this PR. So the things that we talked about for, the small things we talked about for this PR, we can work with David offline and get those cleaned up. And then I think we move forward with this. If anyone else has anything else to say, please stop me. But otherwise, let's maybe move on to the HPA stuff.
So one last thing, right? Like, so I guess making sure multi-replica works, and the other instance waits, and like and whether we change it from init container to a Kate's job for the migration, that can be like that's something like separate. Oh, you know what else we could do? If we're doing a Kate's job, we can also move the like the subsequent default credential creation and all the stuff into that Kate's job too, out of the operator. after
Say that one more time.
like so sorry I'm keeping on this topic, but it's just the idea of it kind of excites me a little bit. So right now, remember, David, that you have to inject put code there to essentially wait for migration to complete and then run AWX manage command. But the case job would be running a AWX container, right? Which means that when it finished migration, it could just go ahead and run those AWX commands to finish up the setting up. So no longer the operator have to do any weird waits. Essentially, operator right now would just be creating everything and then just hang up.
And that's a more Kate's native way to do it too. So
Right.
I love it.
Yeah, I have to say that I do like the idea, and I think we should, you know, it would be wrong not to explore it, right? I mean, I think that there's value here. So, okay, that's good. This is good feedback.
All right. Thank you very much for doing this.
Yeah, thank you very much. Let's keep David talking. And you want to move to the
All right.
HPA stuff?
All right. So here is another thing that so to kind of give the backstory for this is like, you know, it's really hard to right size a deployment for AAP on Kubernetes, especially if you want to auto scale. Right now, there's no way of like spinning up more task pods whenever there's more jobs. Really, the only thing that we have available to us now to handle increased load whenever AAP is running on Kubernetes is, creating more nodes, like processing nodes. But that in and of itself doesn't allow AAP on Kubernetes to scale. So the next step would be to allow us to be able to increase the number of replicas that AAP is running on Kubernetes to handle all the work. And so that is the intention behind this PR. Now, I want to be very careful. This is just the scaffolding, the framework to implement a Kubernetes native HPA, right? It does not provide a recommendation on what an HPA should look like, the parameters that you configure to make it work nicely. A lot of those parameters are very specific to the Kubernetes cluster that it's deployed on. So it is in no way opinionated about that. So I just want to be very clear that this is just the framework to allow a person to implement an HPA for their environment. So by default, no HPA is created. It is what it is today. I like that feature just to make sure that we don't create something that causes disruption and changes behavior for folks. So by default, no HPA is created. This exposes some new configuration options, obviously. The HPA is enabled by specifying task max replicas or web max replicas. Whenever you specify one of those options, then it will go ahead and create the HPA configuration. The minimum configuration for HPA is just specifying a value of one of those that is essentially greater than 1. It goes through and let me see if I can pull this up quickly. Whenever you specify that, it essentially takes the watch and we no longer monitor the replicas in the deployment files itself. So that is now a kind of like a floating option because it's managed by the HPA. That's how the HPA works, is that it directly modifies the deployment. This is the key to this PR is that we don't want the operator fighting against the HPA. The rest is kind of optional after that. The implementation kind of follows what you see for like the pod affinity rules, where essentially we expose options to put in the YAML for that just gets placed into the HPA config. So this is the template, as you can see here. The min replicas is based upon, you know, the normal task replicas or replicas that is specified normally. Then you have the max replicas, and then we just go ahead and if you define like the metrics, we put the metrics in here. If the behavior is defined, we go ahead and put the behavior in there. So it allows for essentially folks to freeform put whatever they want in there to configure the HPA for their environment. We are looking at version 2. The reason why we're looking at version 2 is because version 1 is very limited. Version 1 basically can only do CPU scaling, which is probably the least interesting thing to use to scale AAP on Kubernetes. What we were looking at least on some of the stuff that I'm working on, is that memory seems to be more of a concern for us than anything, just to kind of highlight that. So version 2, API version 2 of the HPA on Kubernetes allows you to specify a lot of different metrics to evaluate whether you should be scaling up, and allows you to control the behavior on scaling down a lot more. It has a lot more things that you can tune on it. If you just go ahead and say, I'm going to enable HPA by just setting like the max replicas, it will create a valid HPA configuration that looks very similar to a version 1 autoscaler. So it'll just be a CPU one. There are defaults for all these options. So whether this is to say again that we're not, this PR is not opinionated about what a good configuration is. All it is setting up a framework to allow a person to specify it. So just because it's a valid config doesn't mean it's a good config. Questions, comments? Go ahead.
Yeah. So I know we talked about this offline, but I do have some hesitation for adding, like for having the AWX operator manage the HPA resource itself. So I'll back step a little bit. I 100% agree with adding the ability to toggle on and off whether the AWX operator manages the replicas field. So like you said, you know, like setting a task max replicas to say 2 or 3, enabling like that logic that basically says, oh, hey, we're not going to look at the replicas field. I think that's great. And then that one step allows users to bring their own HPA. The thing that in my head is optional is whether we manage that HPA resource or not. So maybe we have a separate toggle for whether we manage it, or maybe we don't manage it at all. Or another option is we create it and then we don't watch that resource, so it doesn't do any day 2 management of the HPA resource. So like it wouldn't trigger the reconciliation loop. So we have options for how we can do this. It's just kind of figuring out what is going to be the best for our users and what's going to be, what will they expect, so that we can kind of meet those expectations.
Right. And I honestly, I don't really have a strong opinion on this.
One simple thing we could do is just essentially have a special meaning. Let's say -1, right? It's an integer field. We can set it to -1, and then in documentation says -1 means like we don't manage the replicas, and then you can bring your own HPA.
I like that.
That's doable. Yeah. Yeah. I'm trying to think if there's Yeah, it could just be as simple as that, I think.
I mean, or we could have, like a HPA managed HPA enable or disable. The thing that I'm like just kind of trying to avoid a little bit is like if we don't try and manage the HPA at all, then we don't have all of these new fields on the AWX CRD. Because like there's a lot of different toggleables on an HPA resource. And over time, if we're managing it, users are going to want to be able to toggle the different things. So since it's all just YAML, I think it might make more sense to let the user define that, but document, a recommended approach.
I kind of agree with Christian, and also like we are essentially just moving the HPA resources schema into our resource, right? It's not a pattern that I'm a fan of in general, but we do it. But so like yeah, just allowing us to not worry about replicas would enable people to, do this.
Yeah, absolutely. So you're thinking that maybe if we use, do we want to go ahead and just say if we set the replicas to be a value, like a negative value, that we go ahead and we don't monitor it? Or do we want something more explicit that says enable HPA and then set all the replicas to be 1? Or what are we thinking here?
I'm okay with the -1 approach, but I get that it's a little bit indirect and a little bit hidden, and maybe it should be at this point in time, since we don't we haven't 100% sorted this out.
So remind me, in your code changes currently, task max replicas, is that value is only actually used in the HPA template, right? Like it's not actually used in the deployment template other than just as a conditional?
Right, that is correct. I needed a way to indicate that you wanted to enable the HPA. So if you actually specified that and specified it to be a value greater than the replicas, then I'm like, okay, you want to do an HPA, let's do this.
Yeah, I'd be inclined to have a simpler interface that's just like, enable HPA, like I don't know what you would call it, task enable HPA, and then web enable HPA or something like that.
Enable HPA sounds like we are enabling HPA. Which we are not technically necessarily doing. We just like
maybe task support HPA or web support HPA. Task ignore replicas.
Yeah, that might be the better task. Or well, don't manage replicas, it's too long. Naming sucks. Yeah, I mean, ignore replicas as long as like in the documentation we have a section that clearly says like how to enable or how to use HPA. I think that's going to be the main thing.
Right.
Yeah. I'd love to get some community feedback on this. Anyone who's watching the recording here, if you want to drop into Discourse or Matrix, we'd love to hear from you, your thoughts on how this should be implemented, and what you would expect. So if you're listening, please come talk to us.
I'll tell you what, I like the approach. I guess once we get kind of maybe a consensus on the wording of that, or I can go ahead and put in a placeholder and try to implement the ideas here, then we can kind of proceed in that direction. What does everyone think about that?
Yep. And once, like through experiments, right, we determine what was the best signal to actually influence the scaling. And when we start to get more opinionated about how the HPA should be set up, then we can try to bring those resources into AWX, right? Or create essentially an AWX HPA resource that will manage the HPA itself. Sorry about the background dog.
All good. Yeah, I do think that this kind of builds on the previous discussion in that, you know, the more awareness we have of what's going on with the internals of AWX, the better we can decide to scale. Just, you know, just as much as we have a situation where we want to like know that the task pod is ready and that you know, it has so many resources to be able to handle jobs. It's like, it'd be great to be able to say, hey, you know what? We're at a situation where the task pod is getting a little overloaded. Let's go ahead and start spawning some new ones to adjust accordingly.
All right, it seems like we are at time. Although, Myers, are you about to speak?
Yeah, just some other time, I guess, some meeting to talk about how you might expect that more information to come through would be great. Like right now we have Prometheus style metrics that show the instance capacity that you could use to like scale up and down.
Yeah, I'm pretty sure the way HPAs generally work is like if the CPU usage will go over a certain percentage, then it'll spin up a new one automatically. I'd have to read the docs a little more, but
yeah, version 2 has quite a few checks that you can implement, including some like external checks and command checks. So there's a lot of flexibility there, and that's one reason why this PR is just scaffolding and not opinionated about the approach, because I don't have an opinion yet.
I would love to export more metrics and allow us to make these decisions more intelligently. Like, would love to slap a metrics exporter endpoint alongside our task and web deployment. Just it's been a dream.
Yep.
Well, I love the feedback. I appreciate it. Thank you.
Thank you very much, David, for leading all of this. I really appreciate that. Yeah, round of applause. All right.
indeed. I guess we can probably close this out. If you're watching, thanks for watching. Please chat with us on Matrix and on Discourse. Please, your thoughts and feedback is very important. So, yep, join us next time. When's our next community meeting?
Community meeting is always on the second Tuesday of the month. So the next one will be, let me pop up the calendar. February 13th.
All right. Well, we'll see you then. All right, I'm gonna drop the recording. Oh, I guess I can't.
I got it.
Thanks.